Hi everyone, today we are going to have a look at metals, alloys and polymers, the metals, plastics that you need to know or be familiar with for your GCSE exam. Now the thing that you need to bear in mind with on this is that you just need to be familiar with these materials. You don't need to know them in depth. Okay, you just need to have an awareness because this is quite often coming up in the multiple choice sections of the exam. Now the nice thing about this is that hopefully you've got a fighting chance because you've got some different options in front of you with the multiple choice. As well as that, some of the things in this video will help you with other parts of the exam. So some of the stuff I say, maybe make a note of or make some notes as you go through. Now, if you've got your revision guide, this covers page 22 and 23. So the first thing we're going to talk through is that metals can be split into three different categories. So we've got ferrous, we've got non-ferrous, and we've got alloys. So ferrous metals contain iron. This makes them magnetic, okay, and also it means, now this is the really key thing here that comes up a lot in the exam, they can rust. So when they're exposed to things like moisture and oxygen, they need a protective coating to protect them from rusting. That's really, really important. That comes up a lot in the exams. So ferrous metals, and I'll talk a minute about the types of metals that these are, will need some kind of finish on them. So something like galvanizing or painting or varnishing even will protect these metals from rusting and breaking down when they are used outdoors. Non-ferrous is basically the opposite, okay? So it's the opposite of ferrous. It doesn't contain iron, it's not magnetic, and when they are used outdoors or exposed to things like moisture, they are not rusting away. So they don't often need a finish when they are used in those kinds of areas. Now, alloys are one or more elements combined with a metal, and this is the important thing. You probably know this from science, but this is the important thing here. I've seen some questions before in the exam that say things like, why are metals alloyed together, or why is this a useful thing to do? Some people make the mistake of saying things like to make them stronger or to make them look better. Well, it kind of depends, doesn't it, on what you're doing. So often they are combined just to give them useful properties. For example, to make them harder or to stop them rusting outdoors and things like that. So it combines the useful properties of a range of different metals and elements. So alloys are one or more elements or metals mixed together to give it some useful properties. So the metals that you need to know. You need to know about this one first. So these are our ferrous metals. Okay. First one you need to know about is cast iron. Now this is used in things like those really, really heavy cooking pots that some of your parents might have at home. It's used in things like car brake discs and manhole covers. It is very, very, very strong. It's very heavy, okay? But actually, if it's exposed to a bit of a shock, it can fracture easily, it can break easily. And it's not particularly malleable, so you're not going to be heating this up and putting it into a shape. It's quite often used in casting and things like that. So important thing with iron, it's very strong, it's very heavy, it can be a little bit brittle, and these are some of the products that it's used for. So heavy things like, you may notice these vices here that we use in tech, they're very, very heavy and they're made from cast iron. Right. Next one, this one's important. I'm just going to rub a few things here that are overlapping. This one's comes up a lot. It's called low carbon steel. So steel is basically a mixture of iron and carbon. Okay, so in a way you could already argue that it is kind of like an alloy, but it's sometimes called mild steel. It is a strong, and I wouldn't put cheap, I would go with inexpensive. Okay, and that is a better way of saying that it's kind of like a low cost, because it doesn't make it sound like it's cheap and low quality, it's just to do with the cost. It does rust easily, however, because it is a ferrous metal, so it would need a finish. Okay, so a finish would be needed. but it is very malleable. So where iron is not very malleable, steel, this low carbon steel, is malleable, and it's used in things like car bodies. So most people's cars are made from low carbon steel, nuts and bolts, nails. So if you had to guess about what a metal product was made from, low carbon steel would be a really, really good guess. Okay, it's just a very, very common steel that's used. Right, the next one here, this is the last ferrous metal that you need to know, and you've got low carbon steel and you've got high carbon steel. So this has slightly more carbon in it, surprise, surprise. It's sometimes called tool steel, and it's used, surprisingly, for tools. So things like hammers and chisels and screwdrivers. It is a lot harder than low carbon steel. So where low carbon steel might dent, this will resist things like surface damage, denting and scratching. So that's ideal. Obviously you don't want to be chiseling something and your chisel dents as you are using it. So it is really useful for things like chisels and files and saws and drills. So high carbon steel, think about tools. Okay, and the reason that it's good for tools is it's very, very hard. Okay. Right, next one, we're going to look through all of the non-ferrous metals that you need to know now. So these are without iron, okay? So remember that gives them corrosion resistance, as well as them being quite often on the chemical table of kind of elements as well, quite a few of these. First one being aluminium. This is a classic one that comes up a lot because it has a fantastic high strength to weight ratio. So for how strong it is very light, making it very useful for things like aircraft and things like ladders, that you need them to be light so you can easily move them around, but because you're going to be putting your weight on that, you also need them to be very strong. They're very, very lightweight. Aluminium can be a little bit difficult to join together. I wouldn't worry too much about knowing that. And it's used in things like airplanes, cans, step ladders, all sorts of different things are made from aluminium. So if you needed a product that was to be lightweight but also strong, aluminium would be a good choice. It's also very easy to recycle. So when you recycle aluminium, it can be used over and over and over. So aluminium is a great example of a material that's relatively good for the environment in terms of it being recycled and reused. Right, the next one you need to know is copper. Hopefully you know that it's a very good electrical conductor. So it's quite soft, it's quite malleable, meaning it's easy to squash into a shape, and it's very ductile, meaning it's easy to draw out into a wire. So ductile, I was always told to remember it with, if you imagine a duck, believe it or not, this is a duck, okay? And the way that I was taught to remember it is imagine you stretching out a duck's neck, and it would be like almost like a thin shape, and there's the rest of his body and there's his little feet there, okay? So ductility, just remember a duck with a really stretched out neck is really, really good for stretching out into a wire. Used in electrical wiring and pipes, okay? Mostly because of its great electrical conduction for wiring. Pipes also, it's not going to be rusting or anything like that when it's exposed to water. I'm going to rub my duck away now, so I'm hoping that helps you to remember that little bit. This one is tin, okay, so it's a very, very, very soft metal that has quite a low melting point, and that makes it really useful for things like solder. So the solder that we use at school for electrical circuits is quite often has a lot of tin in it, so it's very, very easy to melt, but also it is quite soft and again quite ductile, so it can be pulled out into a wire. So things like these cans here, tin cans, are normally low carbon steel with a layer of tin over the top to stop it corroding. As well as things like tin foil and solder, those are the main uses for the non-ferrous metal tin. And this one, zinc. If this ever comes up in your exam, what you need to remember with zinc is galvanizing. Okay, that's one of the key uses for zinc, because by itself it's not very strong, but it does this amazing thing with steel that it joins together making it stronger and protecting it from corrosion. So galvanizing as a surface finish uses zinc. So that's a really good way of remembering zinc in terms of it being non-ferrous. Right, these are the alloys that you need to know. So I'm not going to spend too much time on these. So alloys are a mixture, remember, to get better properties. Okay, so for example, stainless steel, this, you don't have to remember this, okay? I'm just giving it there just as an idea. But you can see that it's a mixture of lots of different bits and bobs. You've got iron carbon, so you've got steel basically, and then you're adding chromium to it, which gives it this shiny, non-staining finish. So it is strong and tough and ductile because it is basically steel, but it doesn't rust. So it's used in things like sinks, surgical equipment and cutlery. These two, so we've got brass is a mixture of copper and zinc. It would be very unlikely they wouldn't ask you what the two materials are that make up that material, so don't worry about that. I'm just giving you again an idea that they are mixed together. And brass is predominantly used for things like door handles and musical instruments because it has this really beautiful bronze colour. It looks good, but it still has really good malleability and ductility, meaning that it's really, really easy to shape into the complicated forms here, and it looks really, really good. So it's more of a decorative kind of product. And this one here, this is a little bit different. You might be thinking high-speed steel. You might be thinking, well, isn't that just tool steel again, where we spoke about high carbon steel? These are actually more used for cutting tools. So what are we talking about there? We're talking about drills. So things like drill bits. Anything that is metal and has to spin or is moving at high speed, because what's going to happen is as it's spinning, it's going to build up a lot of heat. And what that means is that it could, you don't want it to be disform, like melting or losing its shape or anything like that. So this is a really, really good way of remembering that. High speed steel, just remember that's movement. So things that move, tools that move in the workshop, you've got things like drill bits in terms of spinning at high speed, okay? So it keeps its hardness even when it's heated. So that is high speed steel. Right, this little quiz was done a while ago. I don't think you can see the questions on there, so I'm going to skip over this one for the moment. So bear with me a minute. I'm going to skip over that for a second because what I want to do is I'd like to move on to looking at polymers. So we've gone over metals. So you might want to pause at this point because we've just done metals, and it might be nice for you just to pause at this point and come back to the video. But polymers are one of the focuses for the exam. So I'm going to go through all of the different polymers that you need to know, as well as some other bits and bobs that you might find useful. Okay, so during the exam, it might be good for you to know the primary source of the material. So we're talking about crude oil. Hopefully you'll be able to recognise and characterise a different range of different polymers. So we're going to go through that in a second. And also think about some of their properties that they have, okay? Especially this, the thermoforming and thermosetting. So thermoforming means it can be heated over and over and reshaped, okay? So what that means is that polymers that are thermoforming can be recycled quite easily, okay? Thermosetting, once they're moulded, they cannot be reheated and reshaped, okay? It just can't happen. So the problem with that is it's bad for the environment, okay? So it's really bad for the environment because those materials would likely have to be burnt, which will give off really bad things for the environment, and also they might have to go into landfill. Right, this isn't, I'm not going to spend too long on here, but approximately 300 million tonnes of plastic is produced each year. The reason for this is it's very inexpensive, it's very versatile, it does some amazing things, and it's difficult to find a product that does all the things that plastic does. And, you know, this is something that we need to get away from now, and things that are starting to happen about us getting rid of all of our one-use plastics. Specifically, one-use plastics are a big problem and something that we need to look at and get rid of. So what are polymers? They are mostly synthetic materials. So they are coming from places like crude oil mostly. They can come from places like natural gas or coal. So I would stick with crude oil because that's mostly what we've gone with. They're usually coming from these finite resources, but now we're starting to think more about where can we get them so that they are going to be renewable and more sustainable. So things like from sugar and from starch. You can actually grow these kind of crops that will produce what we would call a bioplastic. Okay, and these are much better for the environment. So here are the two categories that we need to know. So we've got thermoforming and thermosetting. Okay, so thermoplastics, when they are heated, they go soft and flexible. They can be remolded without affecting the material's physical properties, so it doesn't burn, it doesn't destroy itself. Basically means you can heat it constantly over and over and over without any damage caused, and you can reshape it. So again, these can be recycled. Thermosetting, once this process happens, once they are basically set with heat once, that can only happen once, they then have strong chemical bonds between them which will not separate again. So this is bad for the environment, okay? But the reason that they are used is they are good in places where you need a plastic to resist heat. So I'm not going to talk for this very long. You don't really need to know this for the exam too much, but you can see you've got your long chains of loose molecules for thermoforming, and when it's heated once, you get these crosslinks, which means it cannot be reheated and the shape cannot change. It becomes very rigid. Now, some pros and cons of thermoplastics. Like we said, they can be recycled. They do struggle with things like heat though, because imagine if they were used in a kitchen, they could very easily soften and go flexible, and that's not something that you want. And you know, you can get quite a good service finish with thermoplastics. Some pros and cons. Thermosets, however, they do withstand higher temperatures. They tend to be quite waterproof, so they are good for things like adhesives. So epoxy resin is a thermosetting plastic. They are good electrical insulators and they cannot be remolded. So that's a big thing, so they can't be recycled. So I'm not going to go through this too much because we've covered this before in terms of which manufacturing process you could use with different polymers. You might want to have a go at this quick question here. Which process has been used for the following items? Some of these I can't even really tell what that is, like what is that? But if you pause and have a go at matching which ones of these you think would match up with the products. This one is blow molding, okay. This one could be vacuum formed. This one I would say would be injection molded, because it's quite a complicated shape. Or potentially it could also be vacuum formed. So this is a bit of a tricky question. And this one, because it is maybe like a long piece, I think it might be a gutter. This one would be extrusion. Okay. So now we're going to start looking at some of the different plastics. So we are now looking on page 23 in your revision guide. So you might want to pause here and get that open. And what you'll notice is you see these three different plastics straight away. PET or PETE, so basically peat, is polyester, and it's one of the most common polymers and one of the easiest to recycle. It tends to be really, really good for things like plastic bottles. So polyethylene, these are thermoplastics, okay, and PET, good for plastic bottles. And then we have these two. We've got high density polyethylene, so it's the same polyethylene, but you've got high density and you've got low density. So high density polyethylene is good for things like washing up bowls because it has good chemical resistance. Okay, it's quite tough, it's quite lightweight, it's got good chemical resistance. Low density polyethylene, this tends to be used, it's actually not on your list, so even if you don't listen to this very much, it's good for plastic bags basically, because it's very thin but it can be very, very strong. So lots of good properties with this one. So the first one that you need to have a go at, if you look at the table on the revision guide, you've got the second one down, high density polyethylene, polyterephthalate, PET. Those are those two that are covered here. So here we go. Low density polyethylene, good for things like plastic bags. High density polyethylene, again, we've got the chemical resistance, good for bins and washing up bowls. And polyterephthalate, which you can just call PET or PET. Really easily blow molded. Obviously, that's a really good process to use for plastic bottles as well. Right, the next one that you need to be aware of is something called PVC. This is used on things like guttering and the white plastic around your windows at home. But it also comes, it can be rigid or it can actually be quite flexible. So with the addition of something called a plasticizer, and that's like an additive, you can add that into PVC and it turns a rigid plastic like this for pipes and guttering. It makes it flexible, so things like the boxing glove and the lilo, but also garden hoses use PVC. Okay, so it is quite tough, it's easily extruded, it is really weather resistant, okay, and it's really useful that it's got that flexible, means you can actually wear it, it can move with you, it can be quite soft, all that sort of stuff. Polypropylene, this is a really good one. It is really what we would call fatigue resistant. Okay, again, these are all your thermoplastics that you need to know. Okay, it's called fatigue resistance because what it can do is it can bend over and over and over again. So say you had a piece of polypropylene and you bent it in the middle. If you kept bending that back and forth, back and forth, back and forth, it would not break. Okay, it would keep its strength. So it's often used for things like DVD cases, video game cases, things like the lid of this box here, because that would need to be constantly flexed, going on and off and on and off. So easy to clean, and it has all of those other different types of properties. Quite often it's sometimes turned into fibres for clothing as well. Right, high impact polystyrene, again another thermoplastic. Hopefully the name gives it away a little bit, so it's excellent in impact. So things like food containers, yogurt pots, fast food containers, if they were dropped it would withstand a bit of impact, though every single yogurt I've ever dropped has always cracked, but never mind. It's flexible and lightweight and it's perfect for vacuum forming. We use it a lot for vacuum forming. So you can just call it HIPS in the exam, or if you see it there, HIPS, that's high impact polystyrene, and it's really, really good for vacuum forming because normally for vacuum forming you are making some kind of tray or something that something's going to be put into, and it's got that impact resistance. It's also really easy to mold, so it's useful for a wide range of kind of different packaging products made by vacuum forming. And this one looks a bit complicated and is sometimes called PMMA, but this is your one that you know, acrylic. We use acrylic in school all the time. It's really good for laser cutting. You get a really high quality edge on it. It's versatile. It's quite tough. You might not think that, but it does become brittle if it's thin, which is how we use it, but it is quite a tough plastic, despite this clearly having a massive hole in it. It's quite often used on things like coverings on car lights, that would withstand like knocks and scratches, because it's quite a hard material as well. But it's really good. You can have it completely transparent. You can get it in a range of colours. So acrylic, again, a thermoplastic used in car headlights and also used in like shop signs and point of sale displays for like line bending and things. We've covered that before in a lesson. Right, I'm not going to talk about this very long, but on the bottom of every single plastic product you will see one of these, which is called a recycling code. The lower the number, the more easy, or not easy, but more widely recycled the material is. So PET is right at the top. That's the best one for being recycled. It means that it's likely your area will recycle it. These ones here are less likely to be recycled because they're difficult to process. So you can see that acrylic's not so good. Polypropylene's right down there as well, but these ones at the top, the lower the number, the more widely recycled they are. Right, we are now moving on to, if you're still with me, I'm very impressed, we're now moving on to thermosetting polymers. Okay, so epoxy resin, what more do I need to say? It's an adhesive, you mix it together. It is very, very hard wearing. Okay, can I give you a tip? Thermosetting polymers, if it sounds like a weird name, if it's either got resin or it's got formaldehyde, then it's likely it's a thermosetting plastic. So it's normally used as an adhesive, and it's got a good strength to weight ratio, but epoxy resin, it's hard wearing, resistant to heat because it is a thermosetting plastic. Right, this one is called polyester resin. So already we know it's a thermosetting polymer. It hardens into a resin. It's really good for carbon fibre quite often. Oh, I've made a mistake there, guys. I do apologise. It's not actually carbon fibre. I have completely lost my train of thought there. It's called glass fibre, which you may have heard called fiberglass before. You may have heard of that, fiberglass. So this resin is mixed with kind of sheets of fiberglass, and as it sets rock hard. So polyester resin, thermosetting, and it's used in things like glass fibre. And that's literally what I've just said. It's used in fiberglass because it's weatherproof and it's really lightweight. Right then, these are the lovely formaldehydes that you need to know. So again, it's got a funny name. So it is thermosetting. Okay. You need to be aware of these. The things that they're used for, phenol or phenyl formaldehyde was actually one of the first plastics produced, and it was used on these really old-fashioned telephones and decorative household items like clocks, radios and telephones. Very rigid and very hard, so used for electrical components as well, because we know any heat generated by electricity is not going to cause it to lose its shape because it is thermosetting. So that is the phenyl formaldehyde. Again, I don't think you'll be asked to write that down as an answer, but it could come up in one of the multiple choice questions. Melamine formaldehyde. This one, work surfaces, try and get that into your head. So things like in school, it could be a school desk, but sometimes in the exam, it's often a kitchen surface because it's very resistant to scratches. Okay, it's good with heat, with chemicals and with moisture. So it's really, really good for resisting, you know, a really hard wearing surface in contrast to other materials. And the last one I'm going to talk through, so this is the last one, urea formaldehyde. This is used for things like plug sockets, okay, and it's used also for plug casings, okay, because it's got, again, it's a thermoset, so it's heat resistant, and is very, very useful in these kind of applications because it's never going to lose its shape. Sometimes it's used as a glue as well, but this is the main use of urea formaldehyde. So just try and remember, because it's such a good electrical insulator, so it's not going to transport any electricity through it. That is a really, really good electrical insulator for you to remember, and that's what this is used for. Right, so hopefully have a little pause and see if you can think about these just for a moment as like a little finish off. I'm going to answer these now, so pause if you don't want the answer straight away. So the two categories of plastics, we've got thermosetting and thermoforming or thermoplastics. Okay. Name one finite resource from which polymers are derived. Crude oil. What is the most environmentally effective way of disposing of plastic? Recycling. Suggest a plastic with good electrical insulative properties. Urea, formaldehyde, that's what we literally just talked about. And name two plastics suitable for food packaging. So I would say HIPS, because it's impact resistant, like yogurt pots, and PETE or PET, because it is lightweight. There we go. I hope that was useful. See you on the next video.